Sometimes we come across a vehicle with failures in multiple systems. Maybe the systems don't seem to be related, and we might not have a diagnostic trouble code to help get us started. If you run into something like this, the cause might be a network communication failure. We can analyze the symptoms of the vehicle to help us get a diagnostic plan so we spend less time doing electrical tests. In this video, I want to show you the different symptoms a communications network might show with two different types of failures. We'll be using a LIN network on the 16 Honda Civic, but many of these techniques are universal and apply to other network technologies like CAN and MOST. Well, let's talk about window operation first. We'll start with the driver's window on this car. In this example, all of the switches shown inside this switch are just inputs to a control unit, and that control unit's actually the power window master switch itself. Now this control unit directly controls the driver's power window motor, and it looks like it controls the left side power mirror too. That's simple enough, but what happens when I want to control the passenger window switch? Looking at this diagram, I don't see that the passenger window motor is connected to the master switch, and of course I know that there's no other portions of the circuit because this gray box has a solid border. But if I move further along the diagram, I'll see that the front passenger power window motor must be controlled by the control unit that's inside the front passenger window switch. We know from our Honda e-learning that control modules can communicate with each other through communication networks. And of course we see this dotted white line connecting our passenger window switch and our master switch. If I bring up the details for this connector, see here that pin 34 is described as LIN PW, which would be the power windows. That means the driver switch is requesting the passenger switch to control the passenger window through a LIN message. So what is LIN? I've been talking about LIN, but we spend most of our time discussing CAN. Both of them are different types of network communication protocols. But LIN is low cost, low priority, low end communication. It's just a different network type than CAN. It's used on power windows, seats, door locks, things like that. They're not mission critical. They're not powertrain related. They're not safety related. And LIN also uses components that are usually built into the microcontroller already, so it's low cost and easy for a manufacturer to implement. Turns out for me to move the passenger window with the driver's window switch, I have to use a network. In this instance, it's LIN, and that tells the passenger window switch to move the passenger window motor up and down. Okay, so LIN controls the passenger window, but I know for a motor to actually do work, it's going to take some current. Where do I get the current to operate these modules, and what happens if I lose that current? That's all up to the power and ground portion of this circuit. Let's start with the positive side. I've traced power back from the passenger window switch along this green wire to this 20 amp fuse B15. This fuse provides voltage to the passenger switch, and if I open up details and location, I see it's located here in the instrument panel. If this fuse failed, I'd lose operation of the windows, and it looks like the mirrors as well. And I'll open up all these circuits, and it looks like this fuse is used in all of these other systems too. So I pulled this fuse and it stopped operation of the passenger window and the passenger mirror also. Now I feel like at this point I've got a pretty good understanding of the power side of this circuit. Now I pulled this fuse not only to simulate a blown fuse, but an open anywhere on the power side of this circuit. Once I get it put back in, we'll go ahead and have a look at the ground side as well. G505 is the ground for the passenger window switch, and since the passenger window switch has direct control of the passenger motor, we can say that this is the ground for the passenger motor as well. Now I'm going to use the details tab to find the location of it, and it looks like G505 is going to be on the passenger side of the dashboard. I'm thinking that if this ground wire broke, I'd see that all the other systems that are using it are going to stop working. So I'm going to find its location on the car. I'll disconnect it, and that's going to simulate an open on the ground side of that circuit. And now that I've got the ground open, let's see what happens with the operation of those other systems. It looks like they stop operating, and my components with direct control, like the passenger window switch, they still work okay. Everything that uses network communications to operate, it's stopped at this point. So we see, just like a regular load, a control unit has to have voltage and ground to operate. Open data lines aren't the only cause of communication faults. We saw they can also come from low battery voltage, blown fuses, and faulty grounds. Next, let's look at a different fault scenario. In this instance, my powers, grounds, and data lines are all working correctly, but I've got an internal fault on the passenger window switch. My passenger window works fine from both the passenger and the driver switch, but the passenger mirror, that's a different story. Based off those symptoms and some basic knowledge about the LIN network on this vehicle, we can say that the LIN network's operational. We see in this diagram, LIN has to be reaching the passenger switch to operate the passenger window, but something's preventing the window switch from moving the mirror. A quick voltage check at the switch shows it's not outputting anything to the terminals going to the mirror. Remember, this passenger window switch is a control unit. It's just a little baby control unit. If it has an internal fault, it might lose some of its functions, and if it loses data communications, it'll probably lose all of its functionality. If it has direct control, and it does have direct control of the passenger window, if it has direct control, kind of like our HVAC system, it will still be able to operate some components. But if we lose power and grounds, none of this system is going to work. Now, I'm going to see what would happen if we had an open communication line. Having a look at the EWD, we see that if LIN had an open going into the front passenger window switch, we'd lose our LIN messages after that point. I think the driver's switch would still control the driver's window and even the rear windows. And I also think the passenger switch will probably still control the passenger window. But I don't think we're going to be able to control the passenger mirror. The moonroof, that should work okay. That path is still complete. Back at our car, now I have an open in LIN close to that same front passenger window switch. Now, the passenger window can't be operated from the driver switch, but all the other windows can. Also, the passenger mirror can't be moved from that switch. But I can move the passenger window up and down from the passenger switch. Remember that direct control. Also, the moonroof works just fine. That matched up pretty well with what we anticipated on the diagram. Looking at this chart, I can see that there's definitely a difference in symptoms depending on the type of fault. Next, I want to have a look at the EWD and discuss some of the details of the moonroof system. I see that the moonroof's controlled directly by the moonroof switch, and this fuse over here will be powered up all the time, not just on and start. That means the power moonroof could be told to move at any time, and we tell it to move with LIN communication from the power window master switch. But we know there's no moonroof switch built into that master switch, so who's telling the moonroof to move? If we look closely at this section here, we see that there's more circuits going into the power window master switch. If I hover over that circuit, I can see that this is a CAN communication line. And since we have CAN and LIN at this window master switch, we also know that the master switch is a gateway control module. The body control module is able to command the moonroof using the power window master switch as a translator of sorts. For our last example, we're going to look at a shorted communication line. We know from ELC51 that all communication is stopped when a network is shorted to ground. Specifically, that was for BCAN, but does it apply to LIN as well? Let's have a look at the EWD and then we'll do some testing with this network. I'm thinking that if the network's shorted, that means pretty much anything relying on LIN for operation isn't going to work correctly. So I think my passenger window will operate from the passenger switch, but I don't think it will work from the driver switch. I also do think my moonroof will work from the moonroof switch because it has direct control.
Let's go back to the car and see what really happens.
Like I thought, the passenger window will operate from the passenger switch, but not the driver switch. The moonroof has stopped operation altogether. Now I've also connected my meter and the scope to the window circuit so we can see what the voltage looks like on when the lens circuit is shorted. And you'll see on that oscilloscope waveform, it's very close to zero, it's not moving, and it's the same on the meter. Now remember, we isolate these shorts to grounds very similar to how we do this on simple electrical circuits. We're going to disconnect components and circuits to isolate the location of the short. When I remove this short, you'll see on that waveform that both the meter and the oscilloscope are going to resume communication. Now it seems like a short to ground did stop communication on this network, just like it did BCAN. That means those symptoms are going to apply to most network types. So I've cleared out the DTCs from that last experiment we did, and I realized that also showed me that LIN communication is necessary for the operation of the moonroof. It turns out, since the moonroof doesn't use a switched power connection, the control units are only going to operate when LIN tells them that the vehicle is turned on. When LIN's shorted to ground, the control units don't know that the ignition's on, and they're not going to operate the moonroof. One last note, shorting a communication wire is a quick way to disable communication networks, and it's not going to damage those control units. So in this video, we learned that a short in a communication line disables all communication across the network. We learned that an open in a communication line only affects the control unit isolated from the network. And we learned that a fault in the powers or grounds or internal to the control unit, that'll primarily affect the control unit with the fault. We didn't discuss some of our newer control units, which use a design called Restrictive Communication Protocol. That design disables communications across the network regardless of the fault type. And that prevents us from using symptom-based troubleshooting on those type of vehicles. But the fact that control units don't all act the same, that doesn't mean we can't use these techniques across all vehicles. Remember, symptoms that affect some control units point to opens in communication lines, power and ground faults, and defective control units. Contrarily, symptoms affecting all control units indicate shorts in communication lines, and on certain networks, any of the types of fault we mentioned. Symptoms alone aren't going to be enough to pinpoint the cause of a fault, but in most cases, they're going to help us narrow down the possibilities enough to begin electrical testing. Like anything else, if we understand the operation of the circuit and the system, we can progress through most failure scenarios using our 5-step diagnostic process.